Hello, I see some people are joining in, so let me see how many people. Amy, Calvin, Evelyn, Colby, Hunter, Duke, great. I'll wait a few minutes here. Can people hear me okay? Let me see. You can use the chat. Let me see here.
Yes, we can hear you well.
People... Oh, that's great. So yeah, great. Great. If you want, can you see the screen? Can you see the first slide? Okay. I think you do. Yes. Okay, great. So welcome everyone. I don't know if we should wait more or get it started. And people who join late, they join late, but I don't want you to miss all the things that I have here for you. My name is Fernando Moreu. I think you see me on the video as well. I think you do. And now you see my screen, don't you? I think you do as well. So do people see my screen?
Yes.
Okay. So I'll go ahead and start here. My name is Fernando Moreu. I'm an assistant professor in the School of Engineering. And we are very excited to be invited on this event today. I'm trying to open two screens here so I can follow with all of you and see who is there on a different link. Let me see here if I can join on this other computer. And I have a lot of videos today. I think the majority of the people in the audience is middle school and high school. Is that correct? If people can type in which grade are you in? Can you type that on the chat? And I can see the which year are you in? 5th grade? Okay. Let's see the other grades here. Kobe's on 5th grade. If you want to type your school, that would be also interesting for me. So I can see 6th grade from Hunter, Duke. Other people, other grades that you can type there, so I can see. Okay, Professor Willow Family School, great. Which other grades? Which other 5th, 6th grade? Home school, good. Okay, good. Anybody else? 6th grade and UNM students, excellent. So I'm on the Department of Civil Engineering. Let me show you what did I do before I was a professor. So I have a little bridge here. So in engineering, we build things that you are using every day and you are driving on or living in, or we also build things, maybe design things for energy. This is a railroad bridge. This is a timber trestle railroad bridge. That's correct. And I used to work for the railroad. Now at the University of New Mexico, we do research with the railroad. And this is a railroad bridge. That's very impressive. Great. And this was a project that my students had to do in the class. They had to build a railroad bridge, a smaller railroad bridge. And that was one of the 2 students did this. So they just did a portion of the railroad bridge, and they did a very good job. I gave them the drawings, and they did a mini railroad bridge, that's how you learn. You build a mini one, and then you can build a big one in the future. I have another bridge here. Let me show you. This was easier. This is a truss bridge. It's easier, okay? It's just maybe some of you already built this already. So it's a truss bridge that is designed to carry loads, and the components will have stresses, and in engineering we love stresses, and you would love that too if you come here. So I'll put this here, and finally, I also have a part of a little building, a very tiny building, right? Because as I say, we learn building little things, and then we can do big things. So this is a connection of a building, little bolts and little connections and little beams. And by doing this thing small, you can learn how to do it later on a real building. You could build a laboratory, you could build a hospital, you could build a school. This would be a steel. So in engineering, we like to build real things, okay? What I have today is an introduction to the School of Engineering. I'm affiliated with everyone in the School of Engineering, but we have departments. And I'm affiliated with another 2 departments, the Department of Electrical and Computer Engineering, and also the Department of Mechanical Engineering, okay? So that way, what I cover today, and I also work with computer science. Of course, we have nuclear engineering and chemical engineering. I think that's it. Elsa Castillo can correct me if I'm forgetting. I think we're 6, if I am correct.
Yes, that's right.
Okay, I did. So I passed. So when I asked the students, you have to pass like I did, okay? So 6 departments, because every work that we do is connected, okay? So what I have here today, we're virtually on the National Museum of Nuclear Science and History. It's part of the Smithsonian network nationwide. And I was very lucky to, to go visit there when I moved to Albuquerque. So you haven't been there. Of course, we are in COVID situation and we need to see when that's possible. It's very fun. Today, we'll show you how in the university we are very happy to be here today and talk about science, technology with you. If any student have any question, any moment, you can write it on the chat. And I don't know if you can talk, but I think if you can talk. I like to hear from you, okay? I'm gonna show you the most important people in the University of New Mexico. Are you ready? I think you can also raise your hand or thumbs up. I don't know, you can try that on the chat. You wanna meet the most important people in the university? It's not me. It's other people here. They are the students at the University of New Mexico. They are very intelligent. That's right, the students. Amy Gibson. Yeah, they come from all around the world. They come from New Mexico, they come from Albuquerque, they come from the Southwest, from the East, from all around the world. And they study things that they invent. So the students invent solutions. They build solutions and we work with them. So my students are more intelligent than me. And I'm very lucky that they come here so I can learn from them. They are very creative. They are younger than me. They are faster programming the computer. they're faster building robots. They're faster than me. So they're changing the world. And I'll show you today the kind of things that they do in UNM. And this is, anybody knows what this bridge is on the audience? Let me see. Okay, before we go. Anybody knows? Okay, that's the departments. Anybody knows what this bridge is? Is it in which state? Is it in Michigan? Nobody knows. That's right. It's not the Rio Grande. It's not Taos. It's in Colorado, so it's on the neighbor state, and it's upstream, and it's the Gorge Canyon suspension bridge. So this is a suspension bridge. It looks like the one in San Francisco on the Golden Gate, where you have the cables, or the Brooklyn Bridge, where you have the cables and the bridge is suspending from these cables. And the Taos Bridge is a truss, where the truss is below the bridge. So here the structure is on top of the bridge, and the bridge is suspending from the two main cables, and it's suspension bridge, and Taos is truss, is underneath. So the students and I went to do research in the Railroad Center in Colorado because they love bridges. They took me to the bridge, and I was very lucky to go because it's beautiful there. And it was 2 years ago actually. So that's the students, and that's what I have here for today. And again, raise your hand, or ask anything. I'm looking at the chat here if you have any question, but if I don't hear from you, I'll continue. I wanted to introduce you to how their humans and structures and engineering can have an interface, and we're doing that interface with augmented reality. With augmented reality, we can feel the structure, and also we can see the structure, and we can understand our environment. So if you see the data on real time, you can interact with your environment, you can interact with your city, your structure, maybe your nuclear facility. You could go and repair. We do a lot of work with the nuclear engineering and augmented reality because they are interested in augmented reality. So you will see some of the work that we do with nuclear facilities today, but it can be also with animals. You can interface with animals. So anybody on the audience have a pet, like a dog at home? Let me see. So if you have a cat is okay, but dogs are. We're interested to talk with you later. Cows would be very good if you have cows. We are trying to talk with animals with augmented reality. If you are an owner and you're interested in this area, talk to me later because we're trying to talk with owners to understand their animals. And cows, actually, I'm very interested to talk with Sarah Lambers because I don't know much about cows myself, but I think it could be very beneficial. Okay, so I'll show that a little later. Let's move on here on the bridges. As I said, I'm going to tell you a little bit about bridges because I work on bridges 10 years. So I'm an old person. I worked 10 years with railroad bridges. I'm interested in the interface with railroad bridges or structures. With Elsa Castillo, she gave me an A because I could answer the 6 departments on engineering. She gave me an A. But if I would have given a lower score, she would have given me a B or a C or a D. These grades are for infrastructure in the country. These grades are very low because the structures are old. They have cracks. They have to be maintained. And what we're thinking is, if we can collect these interfaces, maybe we can understand what to be repaired. This is what I give the people, the D+. That's what the final grade of everything, bridges and plans and everything. So that's the letter, the grade that you can remember for America infrastructure. As I mentioned, I used to work in the railroad, and I did a lot of climbing on the bridge, so I could see what to repair. So you see these two men or woman, I don't know, they are hanging from the bridge. They're hanging from the bridge to inspect the bridge. This is a little crane going under the bridge to inspect the bridge. These two pictures, I took them on the top. This is looking for, this bridge is real. We use it. It's very good. It's a lot of holes, but it was working very well. So we want to see how bad are the cracks to make decisions. And then you see this timber bridge, like the one that my students built. But on the real scale, you see, it's similar, right? A little similar. So we expect that with to make decisions to repair them, okay? So what I say is that we need to see how bad the bridges are. It could be the bridges, it could be the nuclear plant, it could be the railroad. So humans, we are humans. We are not machines. So it's very difficult for us to measure data. We don't remember. Computers are good for that. One interface for humans to collect data are sensors, and we can put them on the structure and see the data. Because if with our eyes, we don't see how much the bridge is moving, correct? So I'll show you how we do that. Let me see if you can see this. Okay, it's trying, but it's a little slow. It doesn't want to show it, but that's okay. I think it's not gonna work here, but basically I have a video that doesn't want to show. Maybe let me see if I can show it here. It doesn't want to show it. That's okay. I will show it here. So basically what we have is sensors can tell you how much things are moving. So we'll have a database, we'll have diagnostic tools, and we will have informed decisions. Let me show this to you here. So I will show you how we do it in UNED, okay? I don't know if people can see this video. Can you see this video on the screen now? It's kind of in the center of the screen. So this is what you see on the HoloLens when it's you have a menu in front of you, and you can see the room or the bridge that you're looking at, and you have the computer that you see with your goggles. Okay. We can use it on the bridges. We use it on the tramway. So we can put the sensors on the tramway, and we can see this menu there. Okay. We also use the sensors on rockets. I'll show you how we do that. We put sensors on the laboratory, and this is on the lower left. You can see we run earthquakes. We like to run earthquakes and see if the earthquakes are moving too much. And we work with the national labs. We work with Sandia National Lab. They are interested in vibrations, and they're interested in airplanes and things that vibrate on the. We design them, but maybe sometimes we find that when you fly, they have some strange interactions. So we need to do some experiments again and improve the design and improve the safety. And we do those in the laboratory. And we are interested in dynamics, vibrations, etc. We like drones. We use drones for inspection of bridges. It can be also for safety. We have a program on cybersecurity where we work with officers, the ROTC students, they like to learn about sensors, cybersecurity. Their own cybersecurity is to protect the data that we obtain from attacks. And we program encryption, and we can see what we protect of the data, and we just learn from that. Again, the students are the ones doing the job, so I learn from them how to do it. And this is one example of the sensors that we built. This is called low-cost, efficient, wireless intelligence sensor. And we call it LEWIS. So it's easier to remember, LEWIS. Low-cost, efficient, wireless intelligence sensor. And this is the office of one of my students on the top left. This is their desk. It's a lot of fun, huh? What a nice office to have. And they order, they buy the materials, they design the sensor, and that's the beginning. Then on the right-hand side, you see the prototype. So you have your Arduino, accelerometer, resistor, capacitor, USB card, a storage unit, everything wireless. And you have the switch. It's very professional. That's a student-made sensor, very professional. I was very impressed. And then we put it on the Albuquerque Railroad Bridge in Central. This is a long time ago. And we can measure when the train is coming, like you saw on that. With the data, we can know when the train is coming without being there. That's interesting for us. All designed and made in UNM. And we can do it for long term. So you don't need to go to the bridge. You just leave it there and collect the data that you like. And this is how we do it in the laboratory. You can see the accelerometer. You can see the wireless XB antenna. And this is on the earthquake. So we put it on the shake table. The blue plate is an earthquake on the floor. So it simulates a real earthquake. We have the earthquake data, so we can run earthquakes in UNM. Don't tell the dean, but we do when he doesn't listen. And then we measure with the wireless sensor the earthquake. And we can collect the data with this wireless antenna without any cable and low cost. So that's the kind of thing. And we compare with the commercial. So we can compare that our sensors, the cheap, low cost, are as good as the commercial. And then we are good to go. So we validate it. And I'll show you how good they are. The LEWIS, low cost, efficient, wireless intelligence sensors. I'll show you how good they are. You'll be surprised. This is the shake table, the blue. You see the earthquake. The earthquake is on the, so the laboratory needs to have a very strong floor. So don't do this at home. So when I came to UNM, I asked, do you have a strong floor? The chair told me, yes, you have a strong floor. When you have a strong floor, you can run earthquakes. If you don't have a strong floor, don't run earthquakes. So it could damage the structure, okay? Earthquakes are not good for the structures. So in the laboratory, we have a strong floor on the structures laboratory, a strong floor, and we have the shake tables, the earthquake machines there. And then we compare with a real earthquake, but you need that strong floor here. And then we compare LEWIS with the competitors. So how do you think LEWIS is going to do? Let's take a look. It does very, very, very well, actually. Let me see. Next slide. Okay, so this is the railroad bridge, and this is where we collected the data, and this is how we collected the data we did the railroad bridge first. And then we run the shake table on the laboratory. I don't think it wants to run here, but that's okay. You can see our strong floor, and you see the rail, and you see the shake table, and you see our sensors there. And this is the results. LEWIS is on yellow on the right-hand side. Commercial is on red, and blue is the shake table, okay, the reference. Blue is the shake table, red is the commercial sensor, the yellow is the LEWIS. Very good, okay, very good. So my student was super happy, and I was very happy for them. Very good. This speed, you see kilometer per hour. So it's about, you can divide by 1.6. So you can give you like a mile per hour. So it's about 10, 15, 20, 25 miles per hour trains. So we run multiple trains on the laboratory. Don't tell the dean. He doesn't know we're running trains in the laboratory. And we measure and we compare very good data. And we also did the frequency domain very good because we're interested in frequencies. So we like to measure on time domain. We like to measure on frequency domain because on frequency it could be resonance with the bridge, right? We could have some resonance with the train and the bridge and would move, and that's not very good. So we also like to check the frequency. So with Lewis, owners can use displacements in the field and inform the level of deterioration of the structures and inform those decisions for their operations. And now, I showed you, we also work with students who like rockets because rockets can be interesting to be wireless. For the bridges, you could have wire or wireless. On the rockets, it's more interesting that you can make it wireless. It's more powerful. And we have a LiPo battery of 7.4 volts. We need to make it a little smaller box because the rocket is only, I think it was 4 inches diameter. And we work with the Albuquerque Rocket Society. I encourage you to look it online. They have a website. And they will be welcome, following the safety procedures. And I don't know if they are doing it now or they will do it in the summer. Welcome middle grade students. Convince your parents to take you there, Albuquerque Rocket Society, and you can see, and you can even fly your rocket if that's interesting for you. They are very supportive of STEM. They are very supportive of you going there. And you can also ask me later about this. We also, with the School of Engineering, we work with the Air Force, and we go and do some events with Darth Vader here and their brigade, and you see my students with them. Oh, that's great. Yes. That was 2 years ago. We went there with Elsa and the other School of Engineering directors and do more activities. So hopefully next year we can meet each other and do things together. Okay, so let's move to the augmenting interfaces. This is not me. This is a drawing of any person. And we think if we look into the mind of humans and we connect with data, we can create this interface. I'm going to show you a collaborator that I have in Los Alamos. He's a researcher. Maybe some of you are from Los Alamos. I am not sure. Anybody from Los Alamos in the audience? Not today? Okay, well, so it's an hour and a half from here, a couple hours. And this is David Mascarenas, Dr. Mascarenas. He's wearing sensors on his brain, his electroencephalograms. So if you read something that is difficult, your brain generates a different signal. And your EEGs can measure that you are thinking harder. So I saw someone was homeschooling there, so don't tell your parents because now they're going to be able to check if you are working hard or not with this sensor. You can tell them, oh, I'm working very hard and reading, but maybe now they will buy this and they will check if you are really your brain is actually working. So you can take me for that. EEGs, and it's about $800, so maybe they will invest on that. Yeah, so you can measure the activity in your brain, and you can know also good things. You can know if you are surprised, you will have a different signal, right? So that would be interesting to see. So to have that data, this data here on the right-hand side, can help you to change decisions about what is good or bad. Maybe you shouldn't watch some movies, right? Or you shouldn't, you shouldn't try certain things if you know how bad it's for you. So that's good. That's good to know these things. Okay, so here we can also accelerate training. Imagine if we work with you, we can change the way the classes can be, that you can accelerate your learning if we have this sensor. Anybody knows what this symbol is? That's a very difficult question. Very difficult question. I don't think anybody, and I'm looking at the chat. I hope you're looking at the chat and participating. What is M standing for? That's very good. I see a sign. Yes. It's a sign. So now that we are data experts in this group, now that, yes, Benjamin, a neuron. Okay, that's good because we're in the Nuclear Museum. That's good. I think, Kobe, you are into something here. Benjamin, do you want to say something? You can type something. I don't know if you can talk. I like to hear people, but I don't know if I can. Oh, I have a hand up. Okay, so who raised their hand? Sarah, can you? So I don't know if you can talk. Let me see if I can allow people to talk.
What is the question you're asking me? Sorry.
What is the symbol? What does this symbol mean? This N and this it's a company actually. Any hint?
On your screen or?
It's on my screen. I think I already seen the N.
Yeah, I guess I don't see a symbol. I apologize.
Oh. Can people see my screen?
I mean, I can see your screen, but I see a lot of pictures of the different, like the students and the rockets and stuff. I don't see a symbol.
So I don't know. Maybe it's a little delay. Let me see. I think there is a little delay, Sarah. Yes.
No, that's okay. I just maybe didn't know what you were talking about. I don't know.
Okay, so no problem.
Everybody says.
Okay. So, yeah, I will. Yeah, I will continue here. Thank you, Sarah. That's. Do you have a question or you wanna? Do you have a question because you raised your hand?
Oh, I'm sorry. I need to lower. No, I just didn't.
Good.
Unmute.
Thank you. Great. So is Neuralink? Anybody knows? Okay. Anybody sees the next slide? It shows Neuralink on the screen. I think there is a little delay, but maybe I will pause here to be sure I go on the same order here. So the Neuralink is a company that is relatively new and is invented by a famous person that some of you may know. I'm going to show a picture and see if people know who this person is. This fellow here on the screen. Anybody knows who that person? Oh, no. You know who that person is. Is that it has Elon Musk? That's right. That's right. So he was the 7th richest man in the world. I think he went up a little bit. And this last year, unveiled the use of Neuralink with pigs. He envisions that it could be advantageous to do this is that we were talking about before. Having an understanding of what we feel can be advantageous for multiple aspects, especially in our conversation today. We're thinking about learning, right? Because everybody here in this meeting wants to learn. So I figured you would remember this. I think it's a good idea. Let's see what are the things that we are doing here that we can make this superhuman cognition. If we can augment human cognition, maybe we can have new decisions, new interactions and new decisions. Okay, so let's try. Let's see if that is possible today. Let's see what my students are up to. The infrastructure is a square, the human is a circle, right? So that is how we think. We're more rounded, right? The data is a square. So maybe we can interface the two things. Maybe we can benefit from the decisions of humans with exploring these data sets and these structures out there. And that interface is where we will use our thinking, okay? Maybe we can improve better decisions. That's what we are looking for, better decisions. This is an example of a little interaction with a sensor. I don't know if you can see the hand here. In the hand, I have the data. I have a little circle, and the circle is a little bubble. Let me see. Yeah, the video is not going that well, but that's okay. You can get the idea. And this is another interface where we have the shake table, and we have my student designed this. I don't know how to do it. Okay, the students know how to do it. They program the buttons, and with the buttons, they can run the shake table, and with the buttons, they can see the data in front of them in real time. They are very, it's easier when you don't need to open your phone or your laptop. If you just run with your hands, and they just tap the button, and the data appears for them. That's how they do it. Let me show you other. You see the headset here. This is the HoloLens, and this is what we are changing. We're moving from looking at the bridge with your eyes, which I did, and that's why I have glasses now, with actually looking at data. So you could see the cracks on real time, overlaid on your bridge. This is Dr. Mascarenas, my colleague in Los Alamos. Anybody from Santa Fe today on the call? I see people from Tennessee, which is great. I used to live there for 2 years. Yes. When we open again, I want you all to come, because we can do these things very, very fun if we do it together. When you wear the HoloLens, we did that before. Illinois, I live in Illinois 15 years. That's interesting. Texas, very good. Other states, I see Illinois, Texas. I know Tennessee was there. Okay, so yeah, stay connected, and maybe you'll be here in a short time. So this is what we're looking for, okay? This is for those who like technology, this is how the cameras are inside the HoloLens. Don't do this at home, don't break them. But we break them for you. So you can see how the camera, we have the 4 cameras, so you look like a bird with a stereo sight. Think about, it's an old movie, Iron Man. So then when you have the computer vision, you can see more, because humans, because with 4 cameras can see more. So you can see on 3D. We also have microphones. We also have laser. So with the laser, you can scan your surroundings, and then you can transfer that you project that on your goggles, and then you can see them in front of you. So that's how it works inside. So this is very technical, but I figured you would like to see it. This is the programming, the software. I don't know, anybody on the room? Anybody on the room who likes programming? That is doing programming? Maybe you can type which kind of things are you programming. If anybody is already doing some coding for your sensors in your home school or any other Python, very good. Yes, so we use C#, but Python is very good as well for the data. And we program that in Unity. We bring it in the mix-ready toolkit, and then you can interface it on the deployment. Okay, it's OpenCV Sharp. This is one application here that we did with a railroad. Let me show you, where you can see the rail on real time. We are interested for safety of the worker. So when you work on the railroad, I worked 10 years. I trip on the rail many times because you are busy, you are working, you're looking at the bridge, you're very worried about the train. So sometimes you trip on the rail. You pay attention, but sometimes you trip on the rail. So Sho Komigama, he was a high schooler in Menal. he programmed this when he was in high school for us. So if you are in middle school or high school, you can talk with us, with the School of Engineering. We, I think on the chat, Elsa Castillo put it, we have a lot of activities for middle school and high school, even online. So if you're interested to do things while you're at home during COVID, contact a School of Engineering. There are many opportunities for engagement. And again, he was in high school when he did that for us, and it's very powerful. And it can be learned very quickly. We work remotely these days, so it can be learned remotely. That's no problem. It's impressive for me, but I know it's easy for you. So I know it's easy for you. So I know you can do it. So he's very clever anyway. He's very smart. Okay, so let me go to the next. We're interested in protecting bridges from trucks impacts. Okay, and this is an example of a bridge bumper. We did a bridge bumper to protect the bridge from the hits. This is me, and we built a little bridge, a little bigger than the timber bridge, so I look like a giant. Okay, but this is supposed to be 5 times larger for the railroad. This is the real bridge. You see the real bridge here is about 80 feet long, or maybe, I think 100 feet. And the scale bridge is 20 feet, 5 times smaller, okay, 20 feet. So that's the tiny bridge. And now we hit it. So over your ears, we're gonna have a impact on the laboratory, okay? Cover the ears of your dog. They might get scared. It's gonna be very loud. Or maybe not that loud because it's not kicking in, but I'll show you the damage. I'll show you the damage here. You can see the hit on this HoloLens video. And this is how I inspect it. This you can see. This is me inspecting the damage after the hit with the HoloLens. You see the triangles? That's the mesh that I collect on real time with the laser. And then I can see the volume on real time after the hit. You see the mesh? And then I'm walking around the laboratory and I'm collecting the volume that was after the impact. And I can also climb the bridge because I need to climb bridges, right, when I'm on the field. And when I climb bridges on the field, it's dangerous if I carry my phone and my computer. When I have the HoloLens, I can climb hands-free all the time. That was very good for me because when I'm on the bridge, I don't want to carry things on my hand. So that's what I like the HoloLens. I don't need to worry about my hands. I need them for other things. Yes. So this is Somi. Somi, she's now she's working in Los Alamos, but she was a student in UNM, and she was interested in measuring cracks with HoloLens. So what she did is to measure a crack with the HoloLens. You see the crack. You see this is her inspection. Actually, let me go back here. So what she did is compare the time with the HoloLens. It took her 12 seconds. Without the HoloLens, she had to wear a tape. It took her 30 seconds. So when you do it with your hand, it's much faster than when you have to climb and put the tape. Also, you see the ladder here next to her, that little stair, because the crack was a little higher than her. So she has to use the little ladder to go up there and measure with the tape. It's not that risky, right? This is in the laboratory. But when you're on the real bridge, like I was, I need to sometimes use the man lift or a taller ladder to the bottom of the bridge. And that's dangerous because, you know, the laboratory is safe, but the real bridge is dangerous. So for the field, the HoloLens can prevent climbing on the bridge because I can measure the cracks like Somi did here with her hands without climbing. So that's very good for safety. I'll skip this one. We're working with the Air Force. Anybody from the Air Force on the audience? We work with the Air Force Research Lab. We are interested in satellites This is the laboratory of Professor Fierro. He's an expert in robots and drones. This is one of his robots. It's like bigger than me. So we're interested in talking with robots and augmented reality, because not everybody, like maybe some people likes Python, but not everybody like Kobe likes Python. So if you can move the robot with your hands, maybe it's easier for you to get the best out of the robots, right? So that's what we're working with the Air Force Research Lab. Maybe satellites, you need to be an aerospace controls engineer to direct operations. With Dr. Peterson, we are interested in Alex Sizemore, I think Derek Doyle, Oscar Martinez, their group, they're interested in controlling satellites with augmented reality. So we're working together with them. We'll keep you posted. This is also a topic on safety of pilots. So we're looking into creating a strange interface where you could think there is a fire and you can train. If you have a fake fire in front of you, you can train with it. We are working with the city of Albuquerque Emergency Department. Justin is the lead chief. Roger is Ebner. He's the director of the emergency office in Albuquerque. So he supports augmented reality, and he supports UNM. He comes here, talk to the students, explains the exciting things happening on the emergency department of Albuquerque. They talk about earthquakes. They talk about flooding, any emergencies. Any dangerous emergency, they think ahead of the game. So we work with them. We work with them to prevent emergencies. So with Mr. Ebner, what I learned is that the only thing they do is planning, because when the emergency comes, they need to execute. So the only thing they do is planning all the time. So we like planning in the university, and we like to learn from them. They are experts in planning emergencies. This work is from Maimuna and Jack. It's about dynamics. So I teach structural dynamics and vibrations. That's the class that I'm teaching yesterday, Thursday. They had the midterm this week. And we learn about shapes of structures and their vibrations. These drawings are from Dominic Thompson. He's an undergrad in mechanical. And this is the inspector who wants to see the vibrations in front of them. Other things that, let me see. You see the beam vibrating there, so you can change the mode shapes. First mode shape, second mode shape is the red one, and the third mode shape is the blue one. And this is real time. So that's what Maimuna did. She's a PhD in mechanical. And this is you see the structure is the cantilever beam, so that's the real structure, and she can overlay, she programmed to show the mode shapes on their natural frequencies, like to prevent, and this is the menu. You see the menu, first, second, and third mode. She programmed that with Jack. Jack is also a researcher in my lab. Okay, this is Nasimi. Nasimi is a drone that we did with Roya for her PhD. She's doing drones for inspections, and the drone will inspect the bridge and hit the bridge with a hammer. So this is Nasimi, and now I'll show you the hammer. When you inspect, you can hit and listen and know there is damage or not. That's the human, right? But our ears are not that good. So if the data could be available, maybe we can have the machine to listen to it. So this is the work with Dr. Mascarenas, almost, for a drone hammer. It's a hammer that will go on like a wood picker and listen with the microphone and do the machine learning and classify the damage. And we're working now for rocks inspection with Dr. Stormont, and for the rocks that are anybody from Taos. I saw there were people talking about Taos. So on the roads going to Taos, sometimes the rocks fall and block the road. So we can inspect those rocks that would be interesting to repair before they fall and block the access to Taos, right? Or a high road or any mountain around here. So that drone hammer with a Mascarenas hammer, we can hit anytime, and it's very safe because you don't need to climb, right? So this is some kind of experiments that we did on the lab, and then let me show you the data. The data is so good. You see the training and the testing is almost identical, okay? Almost identical. So I remember Kobe was interested in Python. So we did this, I think we did this with Python. That was 2016. So in the university, we like to work with the national laboratories, and Los Alamos, they're very good in human structure interfaces. So I work with them, the students work with them, and Los Alamos, they are leaders in the world in structural health monitoring. So it's very good for us that we are on the same state, because it's good for our students. Yes, we can help the bridges in New York. So we work also with the states different than New Mexico. And I like Alexander mentioning the New York bridges. We are working with New York in this augmented reality for bridges. I know the retired chief engineer of the state of New York bridges. He just retired, but he's a leader also in sensors and bridges. So he put me in contact now that he left with the other chief in the state of New York. So if you like to travel, stay tuned. You can work with UNM, and then we can send you around the world. That's interesting for us, okay? Yeah, we're very lucky. We have a lot of technologies that people like. So if you like to travel, come here, we'll send you around. This is the matrix, is very good. You see the diagonals means it's a good machine learning. 2 and 3, you see this 15 number in the center. It was because the specimen 2 and 3 were very similar. So that's why I got confused there. But you know that I knew that because I did the experiment. So you can see the region 2 and 3. You see this area, black and pink, it's a little fuzzy. But it's because the specimens, I knew how I did the experiment, so I would change it on the future. But everything was very good. Okay, and this is Brutus. It's a robot, augmented reality. Marlon Ball did that. He worked for Intel for 20 years, and he joined our group in UNM for the cybersecurity program with the Navy. And he's a mentor of youth, people like you, but mostly undergraduates, cadets, but also for youth. So he built robots very fast, and then he built the augmented reality, and then he controlled the robot with augmented reality. He worked with Elijah Wyckoff. Elijah is also programming this robot augmented reality interface. Very powerful. And this is what we're thinking on doing. This is for the future. I don't know if I went over time. I will wrap it up here. This is for learning faster with augmented reality. And for the future, we're working with Malak. Malak she's a student in Menol. She's a high school student. I hope people interested in augmented reality and animals send me a note. I'll put my email here, and they can tell me, because we think we can work together with animals better with the experts in animals. I'm looking forward to hear from you, and we can explore this communication if you are interested. We're working with Lovelace. They have experience working with animals in the laboratory. I always check with the university, the animal section of the university, so they ensure that what we do is protecting the animal. They are experts. The university has a lot of resources for you. So it's a very big institution. I think they've done everything possible that can be done in the world. So because they're so big and they have so many resources, if you have an idea or a question, the university probably already did it or has the answer. It's so large that so far they always have answers for me. So be sure to ask anything that you would like. I don't have anything else. I don't know if I ran out of time or people have questions.
That was actually. I mean.
Yeah, is that David? I don't know if people have any questions. I don't know if people want to ask anything. You can type it there, or I'll just hang out here and see if people want to ask anything. That looks good. Thank you for the opportunity to be here with you today. And if there are more opportunities like this, I'll be very happy to come and talk again. Let me see if people want to see this. And let me see on the chat and see there are questions on the chat. I see one here. Oh, welcome. Thank you,
Dr. Moreu, can you please let them know about in the summer program how we collaborate and you take them to the tramway? What do you guys do?
That's a very good idea. Let me show them a picture. That's a very good idea. I saw you mentioned that. My bad. For those who are here, let me show you what we do in the summer program Elsa Castillo was talking about. This is very good. So let me see and share. Yes, so on the summer, we work with the School of Engineering. I don't know if they can see the screen here. Can they see the big tramway?
Yes.
Okay, so for those who are still here, on the summer, I think there are 3 weeks or 1 week. There are many programs in the summer. So the School of Engineering organizes, recruits youth, I think also middle school. And one of the activities that is successful with them is the sensor on the tramway. And the sensor on the tramway means that in one morning, so intelligent, in one morning, you will be designing a little sensor in the School of Engineering, okay? And on that, then you have a lunch break, and then we go up there and put sensor on the tramway. So let me show you. This is the tramway. This is in Albuquerque, and this is the top is in Sandia. This is way up there on the top. In this is kind of the winter, but it's on the summer. It's actually nice because it's kind of cool up there. And this is how we do the sensors. So we did this with the tramway permission. Okay, so they are very supportive. They let us put the sensors on top, and we put one outside of the car. We put another one on the tower, and this is the location of the sensor permanent. The ones that you would build are simpler. That they did before was the one that you did in the morning, and they just went up there and put it on the floor. So we take the tramway up and measure some of the data. So this is the car, will be the tower sensor, and the cars are the blue and the red, so you can see the data. So the data helps you to know when you're crossing the tower. So you can see here, we have these lines, and you can see where the car is. You see the car on red and blue. So the event 2 is when the car is on the tower. You see that peak. The car continues going up. The blue comes down. The blue comes to the tower 1. That's the event 4. So that's here on you see that vibration there and that peak. And then you can take the tramway, which is very fun. I have an annual pass because I like it too much. I hope I hope the students install sensors next week, actually. So we continue with them non-stop because, we put the sensors outside and everything. So I think the weather gets better. We're going to go last weekend and we cancel. So thank you, Elsa. That's a very good point. Yes.
Yeah, we look forward to seeing that. We're going to have to go and hop into that next meeting. Thank you very much, sir, and we really appreciate your time.
Thank you. Goodbye, everyone.
Have a wonderful weekend.
Thank you, everyone,
too.
and thank
Bye.
you, Dr. Moreu.